Hello and welcome everyone. I am Jay Dalsaniya and in this video we are going to study the question determine if two trees are identical or not. So this question is the part of binary trees and this question is very basic and you don't need to think a lot. So what is the prerequisite of this question? You simply need to know how to travel the tree, how to traverse the tree. That is the basic concept which we are going to use inside this question. Okay, and we are aiming for 20 likes in this video, right? So you guys can like this video and let's start. So first of all, we'll be reading the problem statement. It does not have much thing to discuss about. So given two binary trees, the task is to find if both of them are identical or not. Okay, so you have to just check whether two binary trees which are given to you are identical or not. And based on the input test case, you have to print yes or no. If identical, then print yes, else print no. Right? So let's have an understanding with the help of an example. Okay, so I've written down three different test cases and let's try to analyze all of them. So let's start with the first test case. Okay, so what I'll be doing, I'll be comparing one by one each and every node. So over here, you need to take care whether the node is present on the left hand side or on the right hand side and who is the parent of that node. Okay, so over here, the first test case contains this tree. So I'll be comparing one by one each and every node. 1, okay, 2, yes, and 3, right? So this is your tree 1 and this is your tree 2. I can see they are completely identical, right? So the output for this test case comes out to be yes. And in the question, you will be given a method and you have to return Boolean value for that method. Basically, depending upon whether it is identical or not, return true or false. And in the output, yes or no will be printed. Let's have a look at the second test case. So I can see the first node 4, okay, 5, yes, and the last one 7. Over here, I can observe that these nodes do not match, right? So these two trees are not identical, and hence the output for this test case comes out to be no. Fine. Let's have a look at the third example. Okay, so this is the third example. Let's have a comparison. 4 and 4, they both match. And over here, you can observe here node 5 is present, but over here nothing is present. Node 5 is not present. So although the other nodes are identical, but one of the node is missing, right? So it cannot be said that both these binary trees are identical, right? So for this test case, the output comes out to be no. Okay, so I've taken all different types of test cases which is possible when you will be given two different binary trees, right? So I hope you got a complete understanding of what the question is trying to say and how to approach this question. So let's have a discussion about how to solve this question, right? Let's start. So how to solve this question? So basically, if you want to solve this question, it's very simple. You simply need to travel the tree. So basically, have one pointer in tree 1 and have another pointer in tree 2. And whenever you are currently standing at any of the node, you will follow the same traversal technique. If you are going to follow first of all left traversal and then the right traversal, then both of them are going to be traversed in the same manner. So let's start. Let's understand how to travel the entire tree, how to traverse the entire tree. So I'll be having one pointer that will be P1 that will be pointing to the node of tree 1 and P2 will be pointing to T2. So the node of tree 2, right? So P1 currently standing at P1. So P1 is currently pointing to 1 and P2 is also currently pointing to 1. So what I'll be doing, I'll be following a traversal technique in which first of all, I'll be comparing the root node, comparing the current node, whether they are same or not. And then I'll be going towards the left subtree and then I'll be traversing towards the right subtree. So this is nothing but pre-order traversal, right? So I'll be following pre-order traversal. Currently P1 is pointing to 1, P2 is also pointing to 1. Are they identical? Yes. So what I'll be doing, I'll be making a call to the left subtree. So your pointer will be currently pointing to this node number 2. Now, as you have encountered a new node, compare the values. Okay, I can see, are they identical? Yes. So move ahead. So go towards the left hand side, nothing is present. Traverse back, move towards the right hand side. 2 does not have any right node, right? So what you will be doing, you will be backtracking. So on backtracking, your pointer will again come back to node number 1. And now from this, as you have already explored the left subtree, you need to make a call towards the right subtree. So on making a call towards the right subtree, your pointer will be pointing to this node, both of them. Now compare, are their values equal or not? Yes, they are absolutely equal. And have a look at the left and right subtree. They don't have any left and right subtree, right? So did you find any of the node missing or did you find any of the node not equal? No, nothing has been found such a way, right? So what I will be doing, I will be printing yes in this case. So basically, when you will be returning false, I'll be just showing you in a different example. So you'll be getting a clear understanding what you have to return while traversing the tree. Okay, so now here comes the second test case. Okay, again doing the same process. This is your first pointer, this is your second pointer, right? So first of all, compare the values. Is 4 equivalent to 4? Yes, absolutely it is equivalent to 4, right? So what I'll be doing, I will be making a call towards the left subtree. Okay, making a call towards the left subtree. Currently I'm pointing to 5. Is 5 equivalent to 5? Yes. So make a call towards the left subtree, but nothing is present. So try right subtree, nothing is present. So what I'll be doing, so this node is completely, so this subtree is completely identical, right? Both of them has this subtree identical. So from this point, you will be returning true. So true will be returned from the left hand side of 4. Basically the left subtree of 4 will be returning you true, right? And now you have to find the value, that what is the value returned from the right subtree. So I have completed the traversal of the left subtree. Now I need to traverse the right subtree. So compare 7 and 6. So I can see first of all the comparison between the nodes. 7 is equivalent to 6. No, it is not equivalent, right? So from here onwards, what I'll be doing, from this point itself, I'll be returning false. Does not matter what the left and right subtree will be doing, but I'll be returning false. So the right subtree of this 4 will be returning you what? It will be returning you false. And now let me just clear out this entire drawing and have a clear view. So you can observe that for this node you got one value from the left hand side, that is true, and from the right subtree you got false. So overall you cannot say that this is identical, right? Because you need to have true values written from both the ends. So hence the output comes out to be, you will be simply doing the AND operation of this values which are returned by the left and right subtree. So on doing the AND of true and false, you'll be getting false, absolutely, right? So the overall output comes out to be no. So over here, each and every node will be returning true or false. So basically you will be saying that the subtree rooted at that current node, is it identical to the other tree or not, right? So if it is identical, both of them will be returning true towards its parent node, right? So this is the process which will be following. Now I'll be writing down, let's have a look at this third test case as well, right? So you will be getting a clear understanding. So now let's start. This is your first pointer, right? So we'll be doing pre-order traversal. First of all, check the node value. Yes, it is equivalent to 4, right? So have a look at the left subtree. So left subtree over here, you can see this contains 5 and this does not contain any node, right? So it is possible that sometimes one of the node might be missing, right? So in this scenario, you can conclude that this subtree rooted at 5 is not identical to the subtree rooted at this node, because over here there is no subtree present on the left hand side of 4, right? So this is your tree 2 and this is your tree 1. So from this itself you can return false. So basically this left subtree will be returning you false to the node number 4. So the value 4 false will be returned, and over here as well false will be returned. And now let's have a look at the right subtree. So basically we already got one false, so you already know that end of any false will be false, right? So basically let's say if this returns true, then the overall output will be equivalent to false, hence the output comes out to be no. So basically basic traversal is required, and whenever you encounter any node, just compare the values, both the pointers values, right? And if you find any of the node is null and the other one is not null, then you can conclude that you have to return false in that scenario, right? So now let's have a look at the algorithmic steps. 2 to 3 things are there which we need to keep in mind. And as I'm going to use the recursive approach, we need to have one of the base case, right? So what can be the base case? So base case can be the null values. It is possible that the pointer 1 is also null and the pointer 2 is also null. So in that scenario, it means that you have reached the end of the tree. So basically there is nothing present, subtree is not present. So that concludes that you have to return true at that point, right? So let's have a look at this algorithm. So now the first base case, the first thing that we need to check is that if we have the pointer 1 is also null and the pointer 2 p2 is also equivalent to null. In that scenario, we can conclude that you can simply return true in that sense. Okay, fine. Now what can be the other scenario? See, the other scenario is that p1 and p2, both of them are not null. p1 is also not null and your p2 is also not null. If both of them are not null, then first of all, what you need to do? First of all, you need to check the values of p1 and p2. p1 dot data, is it equal to p2 dot data? Yes or no? Okay, so whatever is the value, it might return true, it might return false. right? So you have to check this value. Then what you have to do, you have to make a call towards the left subtree and the right subtree, and both the subtrees will be returning some value, either true or false. So you simply need to have the AND operation, logical AND of all this values. So I'll be making a call towards the left subtree, p1 dot left and p2 dot left, right? And again, what I'll be doing, I'll be making a call towards the right subtree, function call p2 dot left, I mean p2 dot right, basically right subtree, right? And you can do have a call at the p2 dot right, right? So the end of all these values will be concluding whether the subtree rooted at that node are identical or not. And at the end, what can be the other scenario? The other scenario can be that p1 is null and p2 is not null, right? Or it can be p2 is null but p1 is not null, right? So in that scenario, you know that the output is always going to be false, right? So the third thing is that if that any of the above condition is not satisfied, then you can simply return false, right? So this is the entire algorithm. Okay, and now let's quickly write down the code for the same and let's have a look at the implementation part. Let's see. So over here, this is the entire implementation part of the algorithm which we saw right now. I have implemented in Java, but the same can be implemented in other languages. Just take the reference of the algorithm. Okay, so now over here, the first condition is the base condition. If both of them are null, over here, the pointer which I have used is root1 and root2, right? So don't confuse yourself. It is root1 and root2. So if both of them are null, then you can simply return true at that point. Now, if both of them are not null, then you have to first of all check their values, right? So I am comparing the values of root1 and root2. And then what I am doing, I am making a call towards the left subtree of both the root1 and root2. And then I am making a call towards the right subtree, right? And all these values will be done logical AND operation, right? And then whatever is the conclusion, that conclusion will be returned from here itself, right? And if this condition is not satisfied, then it means that either of them is null, right? So in that scenario, you know that the output is obviously going to be false, right? So I have simply added the return statement that contains false value, right? So now let's have a look at the submission. Let's try to submit and let's see the acceptance. So we can see that the problem has been successfully submitted, and let's try to analyze the time and space complexity. What can be the time and space complexity? Try to guess. So the time and space complexity obviously is going to be the size of the tree, right? So whatever, how many nodes are present? Let's say both the trees will be containing n number of nodes, right? So the overall time complexity will be total number of nodes required because you are going to traverse the entire tree, right? So the overall time complexity will be order of n. And what about the space complexity? So the space complexity will be the size occupied by your recursion, right? Recursive stack. And what is the maximum possibility of the size of the stack in this scenario? It is possible that the stack will be filled as much as the height of the tree. So what can be the height of the binary tree? It can be log n. So the space complexity in this scenario will be log n. And let's see what is the expected time in space complexity, order of n and order of height of the tree, right? So it is completely matching the expected time in space complexity, right? So this was it. This was the entire approach for the question determine if two trees are identical. If you really enjoyed this solution, do hit the like button and share it with your friends, and do comment down your approaches in the comment section, right? I'll be meeting you in the next video. Thank you for watching. Bye bye.